Utility Fleet World. It's Kurt Moreland, Associate Publisher, Utility Fleet Professional, and we're here with another edition of Under the UFP Hood. And we've been doing a bit of a series on EVs and kind of an update and what's going on in the industry, which is very pertinent to our market since our electric utility fleet managers are leaders in that area. And we're very happy to have with us Stephen Israel. Stephen is with ChargeTronix, and looking forward to having a conversation with him on a deeper dive into the subject of charging. So welcome, Stephen.
Thank you very much, Kurt. Great to meet you and glad to be on.
Yeah, tell us a little bit about yourself, how you got into the charging business, and also a little bit about ChargeTronix.
Thank you. Yeah. Over here, I'm at ChargeTronix. I'm a VP of operations, and I've been in the space for about 18 years. So actually what that relates to is that I've actually been here longer than the Tesla Roadster in the space, just overall. I was with a couple companies, everything from battery energy storage, with a big CPO in the past, and even a couple different manufacturers of EV charging. But, really enjoy the space, got into it early, I really enjoyed energy systems. I saw this as the future really for mobility as we move away from fossil fuels or just a mix of different mobility types and fuel types. Saw EV charging as one of the most prevalent kind of in the future. So it's been a great career path for me. ChargeTronix, what we are is we are a manufacturer and distributor of EV charging. We have extremely wide breadth of product, which makes us different from a variety of different of others, especially for fleet operators that are looking kind of, where their utilization or their different types of use cases are a mixed use. We have products that range from 16 amps to 80 amp on the level 2 side. So everything from kind of residential to commercial. And then on the DC side, we have 30 kilowatts all the way up to 480 kilowatts and growing over the next couple of years. So everything from your, light duty, kind of even, putting them in your different employees' houses, all the way to putting them in, commercial facilities and DC charging large, commercial vehicles. What differentiates ourselves is that we really focus on not just the charger hardware and the distribution of that, but also of the post-sales support. So we're really looking at kind of, in the past, I think the manufacturers that are out there have really looked at trying to sell the asset. We're looking at this as if our real work starts after we've sold that on earning. Those are where we differentiate ourselves.
Yeah, that sounds really good. So just to clarify, you're not selling a particular brand of EV charger. You're kind of like a, I don't want to say broker, but you're kind of, tell us a little bit about that relationship that you have.
Yeah, I mean, we have key strategic relationships that we're distributing and even manufacturing, having input on the design side with a couple of our key technology partners domestically. So we're bringing the products to market. We're have the full engineering behind it, and we're supporting those chargers in the market. Like I said, everything from AC all the way up to DC chargers.
I remember in the market, there used to be a limited number of chargers. PE comes to mind, and maybe a couple of others. I've been amazed at each trade show that I go to, the amount of chargers options out there. So tell us about some of the vendors that you work with, or some of the different charge companies that you work with.
Yeah, I mean, what we are is we're a hardware supplier, and we also we support everything from CPOs, as you would know, so some of the larger CPOs in the marketplace, as well as the fleet providers and supporting their needs on the back end side. You may not have heard of ChargeTronix before, but you've seen our chargers out there. We generally white label for a lot of our customers. And so they're everywhere in public space, behind the fence applications, at dealerships, so on and so forth, kind of in the different markets and the verticals that we support.
That sounds really good. So I've always wanted to get kind of a general outline on what chargers go with what type of vehicles. So can I use the same charger to charge my Mustang E as I can my Ford Lightning pickup truck?
Yes. So, over the last couple of years, standards have formalized. So, you can use the same AC and DC chargers across both. I think what we need to just make sure is that the use case that you're utilizing that vehicle for matches, right? What your need is. The Mustang, for example, has about an 80 kilowatt hour battery pack, whereas the Ford Lightning has a 135 kilowatt hour battery pack. So, you need about twice as much power on the Lightning to get the same amount of range, roughly, right? Because of the size of the vehicle. So yeah, it'll definitely work across both, but the power flow is a little bit higher on the Ford F-150 versus the Mach-E, but also, you need more power to get the same amount of range on the vehicles. So, but yes, as the space is today, AC charging is unified across the different makes and models. In some vehicle cases, you do have to have adapters to go from what is considered J3400 or NACS in the space over to J1772. And on DC side, we have a similar kind of alignment that's happening. But that's been a little bit of a change over the last couple of years, where we had CCS, combo coupler standard, that is kind of converting over to NACS in the next couple of years as well. But again, adapters will be available, supplied by the different OEMs, or even available on the aftermarket side to make sure that, like you said, all chargers will work with all vehicles out there in the space.
Yeah, so just to clarify, because at conferences with some of our readers, from what I understand, the goal is to reach standardization, but we're not quite there yet.
Yeah, I would say, in the space, living in the space, up to 2 years ago, I believe everybody believed we had standardization across the industry, minus Tesla, right? Tesla was the one with their own proprietary connector. And then what we had about, November of 21 standard, Tesla kind of opened the NACS standard, generally and vaguely. And then about February, March, you had, GM or Ford decided to kind of potentially launch and switch over in the 24, 25 timeframe, and then GM. And then, as the story goes, all the other OEMs continued to go over. So yes, we are working towards standardization, but we had a little bit of a hiccup in that over the last 2 years. And we're starting to see some of those vehicles coming out with the NACS connectors, but very quickly, NACS will become the prevalent connector out there. It'll become the prevalent standard on the vehicles, because the units sold of vehicles is so much more than it was in the past as well.
Wow, I just learned something new and very important. So that's thanks for telling us about the NACS. I wanted to go into a little bit back to the levels. So can you walk me and our listeners through level 1, level 2, level 3? I believe there's even a level 4. Maybe there's now another level. The different levels of chargers and what they're best suited for, maybe vehicles or applications.
Yeah, absolutely. So there's a couple different levels that are kind of standards on the SAE standards, and then there's some marketing kind of levels that you'll see out there. So we'll kind of go over both of those, right? So what you have is you have level 1. And level 2, those are generally used for just AC charging, as we call it. So what you do is you take AC power from the grid, you put that directly into the vehicle, and then the vehicle has an internal charger or inverter that converts that from AC to DC power that charges the battery. Level 1 charging generally goes up to about 1.7 kilowatts. Which is effectively 5 miles an hour. Think of it in miles an hour, because that always relates a little bit more, right? So if you charge for 2 hours, you get 10 miles, charge for 3 hours, you get 15 miles, right? Level 2 is a wider range, and that is utilizing the same AC circuit as you're doing, but you're using 2 lines and a ground, for those that are familiar with AC power kind of connection points. And that will charge at up to 44 miles an hour. So significant difference, 5 to 44. And that's because you're using a second line for a higher voltage range. And then you're also going up to higher currents, up to 80 amps. Then you switch from what we call AC charging, which is level 1, level 2, to DC charging, which is typically called level 3. Now, the key difference here is that instead of doing that conversion of AC to DC on the vehicle, you're doing it off the vehicle, right? So that's why these chargers are bigger. In a lot of cases, they have fans or other things. They have a lot of power electronics inside of them, right? So this level 3 generally ranges from about 30 kilowatts up to, let's call it 400 kilowatts in today's kind of vernacular, right? Now, generally, what people say is now marketing, you call that level 3, but then marketing will say things like HPC or hyper charging, right? That would be generally when you get above 200 kilowatts, then some marketing folks have kind of called it hyper fast charging, right? Or HPC. So those are kind of where you talk about the states and the standards that exist today that you can actually see in the marketplace as you see it. Now, there's new standards coming out, especially for your fleet kind of operators that they've probably heard, which is MCS or Megawatt Charging Standard. This will go to a larger connector that has power levels that can go up to in excess of 2 megawatts, right? So really trying to get to the point where you can have parity with diesel fueling rates and such, to have really a parity in terms of the utilization and the use case.
Wow. I've never had anybody explain it to me like that. It makes total sense.
Glad I could help.
Yeah, I'm really impressed with your knowledge, and I can see why your company has been very successful. Do you guys get involved in hydrogen at all? And the way that our editor explained it to me is hydrogen is like having like an onboard charger, and is probably going to be more applicable for over the road trucking and things like that.
We don't get included with hydrogen. It is kind of one of those other mobility fuels that exist. If you look at the way that I look at hydrogen personally, is hydrogen is effectively a battery, right? It's a method for storing energy. You have a fuel cell that is effectively your motor per se, or your inverter, right? And that's what a fuel cell is. So it's converting that chemical hydrogen energy into electrons that's actually going to the drivetrain for the vehicle. Some of the advantages of hydrogen are that it's got a higher power density. So in a smaller kind of footprint, you can fit more of it. So, but some of the disadvantages is that, hydrogen fuel does take a lot of power to make that, right? And you don't have hydrogen refining or hydrogen generation available everywhere. So, you have to actually invest in those infrastructure assets, or have, pipes or a method for transporting that to it, kind of similar to gas, whereas electricity is prevalent in everywhere. So you're just connecting to these different grid points that exist.
So true. So true. All right. So anybody who follows my podcast knows that I love to travel. I love the outdoors. So I always like to take kind of a halftime intermission and have our guests share a celebrity or wildlife encounter. So I don't know if you have one of those to share with our group, but I always love to hear one of those.
So I live in Southern California, but not really too into the celebrity type. So I try to leave those alone. So we'll stay away from that one. But from a wildlife side, no real encounters, but just always scared, right? I would say I live in Southern California, done a lot of deep sea fishing and scuba diving and such in my life. And for as much time as I've spent in the water, some of the things that always scare me is when I go out and do like a lobster night dive. You're effectively, going underwater with a tank or without a tank, sometimes in kelp patties and things like that. And you're trying to go down and grab lobsters with your bare hands. But what's always scaring me is as you're down in these kelp patties, you never know what's around the corner. And I swear, for as many times as I've done it, it does not matter. I'm always scared that a shark's going to pop out around the corner and look me in the eyes face to face, even though it'd probably come from behind. So, luckily not an encounter story there, but just always kind of something that's front of mind whenever I'm doing it.
Well, I just learned something about the lobster diving. I mean, diving during the day is challenging enough. The fact that you do it at night, that's pretty mind-blowing. I imagine you must carry a pretty good spotlight with you, or?
Yeah, they're nocturnal, so they come out at night. So when people do trapping or diving or whatever, they're generally doing that at night. So yeah, you bring a light down with you, and legally you have to catch them by hand if you've got a tank on you. So yeah, you literally try to grab them by the back, of the abdomen, and kind of hold on to them. And then when you get them, then they'll kind of hold on to you at that point, right? Because then they're just trying to hold on for dear life.
Have you ever had one turn around and grab your fingers or give you a well, I know at the Red Lobster, they have rubber bands around their claws, so you don't have to worry about that happening to you there.
Yeah, but yeah, right. Well, when we do it on the West Coast, on the Pacific, they have a different type of lobster. We call it spiny. So they've got the long tentacles, none of the actual claws like you're familiar with on the East Coast. But yeah, I mean, you're using gloves so that you're not screwing up your hands as well.
Wow. Well, again, I learned something new. I didn't even know that there was lobster diving. That sounds like a pretty cool sport. So thanks for informing us about that. And now I have new appreciation of where lobsters come from. So let's get back to business. I kind of want to move on the second half of challenges with charging. So up in Michigan over the winter, some utilities talked to us about they had some sub-zero temperatures, some freezing rains, and how that affected their charging stations. Do you see in the future more applications of solar, or do you recommend having a generator backup for your solar charging stations?
Yeah, I'm not sure. Solar to me is not really a viable long-term solution. I mean, kind of going back to just the calculus of it, right? Let's just say you have a 150, square foot kind of panel set, which is kind of your typical average residential system. That's about 2 kilowatts. That equates to that's about 2 kilowatts. The average size for a home is around 9 kilowatt solar system. So kind of to put that into context, that's about 15 to 20 miles an hour. So, maybe for emergencies that would make sense, and maybe overnight kind of applications, but solar is not out overnight, right? So it's really going to be, you would have to get to 200 miles or so. You would really need 10 hours during the day to be able to kind of get you 200-mile range on a typical residential solar system, right, per vehicle. So to me, that's not really a viable, like long-term or emergency kind of usage. But what does make more sense is the battery energy storage systems, So, the utilities, the grids, they're utilizing these for peak shaving instead of using peaker plants, and kind of grid stability. These are also available aftermarket for residential locations. And that is in addition to or in replacement of kind of a generator set that you've described before, where you can actually do some off-peak kind of utilization kind of for your rates as well. So, yeah, but I mean, we do live in the United States, one of the most reliable, if not the most reliable kind of grids, in the world. And really, that's a handful of times outside of some real natural kind of, emergency conditions in which kind of we're encountering those.
And then what are the studies or any findings you have on how weather is affecting electric vehicles, whether it's heat, cold, or taking into consideration, like, for example, California, hilly territory versus I live in the Midwest where it's the flat plains. Do you have to kind of factor it in with your range, some of those things?
I mean, yeah, the short answer is yes, right? For the range, as you go to higher elevations, just like hiking or anything else, you exert more energy, right? So that is absolutely true. But on the counter, when you go the downhill slope, now you're generating energy as well. So it is not linear. It is not fully efficient or equal in terms of a flat surface, but it does you do generate it on the backwards way. related to the kind of the different climate situations, yes, a battery does require to be taken care of, right? So that's what you have things like thermal management systems inside the vehicles to keep the batteries either warm or cold. To do so, you could be expelling some additional energy and making a little bit less efficient to do that. But in terms of the operations and the efficiency, definitely some of the chemistries and some of the battery management systems on the vehicles differ very heavily on how efficient they can be in those different conditions. But the industry is definitely getting significantly better on this, right? Some of the earlier vehicles, maybe like the Nissan Leafs, some of the first generation ones that came out, they had some pretty severe degradation of battery over time. And that's because they were not doing anything in terms of thermal management. They had a sealed pack, and what they were doing is they weren't even cooling it in any way with passive air or active air or liquid at all. So those stories of, those at the time, which seemed like a lot at the time, but is not now, a 90-mile range, right? Whoa, turning into, a 65-mile range, which is severe, right? Nowadays, you have much less degradation because you have either management via active airflow or you have glycol-based cooling systems on these vehicles. So they're making sure that the batteries are in a nice thermal operating condition during their life so that they're not degrading very much, but then they're also operating in better conditions during their normal operation. So you can get full power charge, full power discharge, so on and so forth.
Yeah, great points. I remember when I got to test drive a Volt, which is no longer manufactured, and I think the range was 45 miles, which for commuting locally worked out great for me. But now it's pretty amazing to see some of these ranges that are being reported 200, 300 miles, etc.
Yeah, always take them with a grain of salt for what's published, at least in my personal experience. But yeah, maybe I just have a heavy foot,
I actually knew a guy in a fleet group that I was with who he would actually test them. So that was kind of his thing, and I think he had a pretty successful business doing that.
Absolutely, there's a couple of guys out there that are doing that today. A lot of reviews and very successful. So it's having a control. Maybe my right foot's not a very good control, though. I could tell you that.
Well, the last thing I want to talk about is when I'm at the trade shows, I see companies, or I should say vendors, that are promoting software that makes your charger more efficient or is supposed to reduce your electric bill because it charges your vehicle at certain times. You may have even mentioned this before, I think. Can you tell us a little bit about that?
Yeah, so we partner with those as our fleet management systems or back-end operating systems that'll do that. They utilize certain call-outs like Smart Charge Profile on the chargers to actually curtail or limit some of the outputs on those charger assets. The key thing here is not just being able to control the charger, but also having the telemetry on the vehicles as well, because you need to know how far the vehicle needs to go the next day or the next hour or, the next week, right? So that you can effectively make sure that, yes, as you're managing the power input to the overall facility to be the most efficient, you're also making sure that your assets are well suited or ready to go kind of when they need to be. So it's more of an overall holistic look to make a successful system there, because you have to not just look at the chargers, but also at the vehicles and the different operating conditions in a predictive kind of example. The great place for this to be used is in a behind the fence fleet application where it's a very predictable use case for what these vehicles are doing, plus or minus some factor of safety. So there's a couple different providers that are out there. We partner with most of them, if not all of them, in providing hardware for them as part of their solution for going to market.
And you found these to help out maybe reduce the overhead a little bit?
Yeah, I think, it's you're doing a couple things. Like right now, you're reducing the overhead for some applications, but also you're looking at it also expanding that infrastructure. So say today you have 5 vehicles. You maybe bring in enough infrastructure for the 5, maybe 4 vehicles, and you're trying to manage just that power. But as you start to learn kind of the use case and get more controls around what the predictive kind of analytics look like, you might be able to take that infrastructure that's for, line to line or 1-to-1 for 4 vehicles that you actually stretch to 5 because you're not utilizing it 100% of the time, and actually turn it into 8 chargers or 10 chargers or 12 chargers. So you can actually, as your fleet grows, you can manage your infrastructure assets more effectively to be utilized for more assets rather than having to go back to the utilities and get additional connection points or even bring in different switch gears or transformers or whatever upstream.
Yeah, I've heard that at some of the trade shows that you really want to plan for future growth of your fleets when you're setting up your infrastructure, not just on what you need today.
Oh, always, right? So one of the things that I always recommend is when you're opening up the ground, put more pipe in the ground, right? Put more availability to run more power to different places, because civil work or that kind of underground excavation work is always extremely expensive to do it a second time around. But as you're saying, looking toward the future, looking toward where you want to go in terms of long-term play, yes, as you do construction, it's always cheaper to do that incremental additional work rather than to go back, tear it up, and go start from scratch again, because you're effectively doubling that cost or getting close to, rather than incremental increases. The challenge is just, putting that capital infrastructure in the front end is always something that just, different companies have to weigh with, right?
Yeah, thank you. That was a good way to put it. So in kind of wrapping up, I'm going to ask you to look in the crystal ball. Lately the media's kind of been a little bit down on the EV market, but I still see all kinds of EV Amazon trucks zipping around in our neighborhood. So, look in the crystal ball and give us an outlook as to where you think EVs are going to flourish in the future.
I would hate to give you a timeline, because I think that inflection point that everybody has always pushed more to the right. But the way I see it is that e-mobility or electric charging and electric infrastructure with electric transportation is the future. I think right now we took a little bit of a couple steps forward and a step back. But if you look, vehicle sales are at 8% of total vehicle sales. They're even higher in California and some of the other coastline states as well, related to EVs. And I see this to continue to grow. This is not something that is going to go away. It's not a question of if, it's a question of when right now. So, and I think that you're seeing that in the investment that the different OEMs and the infrastructure investment acts and such are making. So we're all moving in the same direction. We just may have a different end date, kind of from where we were about a year, 2 years, 3 years ago, and it continue and it's always a line in the sand that we're looking at.
All right, good perspective there. I want to thank you very much for doing. It figures you're a lobster diver, because that must have helped us with this deep dive into EV charging. You're a wealth of information. It's been fantastic. And thank you, Stephen, for being our guest on this podcast. Really appreciate you sharing your time and your knowledge with us.
Thank you for the time, Kurt. Really appreciate it.
Well, this is Kurt Moreland, Associate Publisher with Utility Fleet Professional. And just want to sign off here, but by saying to everybody, roll safe out there. And thanks again to our guests at ChargeTronix.
Cheers. Yeah. Thank you. It was a pleasure.
Get the latest insights and strategies for fleet managers delivered directly to you. Subscribe to Utility Fleet Magazine at no cost. Digital or print, the choice is yours. Visit utilityfleetsprofessional.com to subscribe today.